Hey folks, since in the previous session we have defined two functions which is all about common underscore word underscore count underscore minimum, and along with that we have also defined a function for our maximum stuff. So let's try to implement or let's try to apply both the function on top of your data frame so that you will end up getting two new features. Let's try to apply that. So I will say, hey, again, if I will say df.head of 2, let me execute. This is typically the first two observation of our data set. So we need to apply both the function on top of our df data frame, or we can say we need to apply both the function on top of each and every observation of this df data frame. So let's try to apply that. So we will say df.apply lambda of row. Again, let's understand. I will just explain just in a couple of seconds, just in a while, what this row stands for. Over here we have to say we have to apply this function. We have to apply this function on top of each and every row where we have to consider our quotient 1 feature, and along with we have to also consider our quotient 2 feature. Now let's try to understand what this actually stands for. So using this apply function, we are going to say, hey, can you apply all the stuff on top of your df data frame, on top of each and every row of df data frame? You can say as on top of each and every row of this df data frame. Now let's try to understand the flow of the entire statement that we have written. It means I have to apply this function or a custom function what we have defined in the previous session with respect to CWC underscore minimum or common word count underscore minimum. This is the function that we have to apply on top of each and every row of our quotient 1 feature and on our quotient 2 feature. And whatever value it will return us, using our row as a pointer, we have to store all the values. So the moment I will execute this line of code, we might end up getting all the values in the form of numerical nature with respect to our all the rows that we have. So let me show you all the stuff. So what I will do is, if I will execute this line of code using Control plus Enter, just in a couple of seconds. Now unfortunately you are getting a key error. Let's try to understand what this key error says. It says, hey, you do not have any feature as quotient 1. Let's try to cross check that. Now the moment I say hey, df dot columns, let me execute this line of code. Sounds good. Feature name or sounds good. Now one more parameter, let me show you one more thing. The moment I will press shift plus tab over here, now here comes the signature of the entire function. Again, by default the value of axis is 0. Let me show you the entire signature, what this axis actually stands for. So if the value of axis is 0, which is by default, it means we have to apply a function on each and every column. But as we have to apply this function on each and every row, hence we have to customize the value of axis. So in such case, you can say as axis equals to 1. It means you have to apply function to each row of the data frame. Let's try to do this. So we will say axis equals to 1. The moment I will execute this line of code, you will end up getting all the different numerical value. Let's try to store that. So this time, first and foremost, let's try to define a feature as, let's say, CWC underscore minimum. Cool. Let me execute this line of code. And let's try to apply one more function which is all about common underscore word underscore count underscore maximum. And the feature name is all about CWC underscore maximum. Let's try to execute this line of code as well. And the moment I say df of head, let's say 3. Let me execute this line of code. And let's try to scroll it to right. Now you will end up getting two new features which is all about CWC underscore min and CWC underscore max. That's what actually this feature says. So let's try to touch upon what this problem statement says. Again, as far as this problem statement is concerned, where we are going to touch upon one more feature which is all about create underscore common underscore stopword underscore minimum. Let's try to understand what this feature actually stands for. So our previous sentences were nothing but, let's say, I love AI. The second one, which is S2, which is all about, let's say, I love AI, ML, and let's say DL, which is all about deep learning. So again, if I have to create this feature with respect to, let's say, both the sentences that we have, and I have to figure out what can be the value of create underscore common underscore stopword underscore minimum. Hey, can you come up with the value of this feature? The second feature is all about common underscore stopword underscore maximum. Can you come up with the value of both the features that you have, considering if you have such sentences? So it basically means I have common stopword count. I will say I have common stopword count gets divided by minimum of length of total stopwords in S1. So let's say S1 underscore stopwords. Let's try to rename it as, or let's try to name it as S1 underscore stopwords, comma, length of S2 underscore stopwords. So in such case, common stop count is 1 because I is common in both the sentences. So I can say 1 gets divided by minimum of in this I have only one stopword, which is all about I. In the second sentence, I have 2 stopwords. You can say I and this one, and I will say minimum of 1 comma 2. You will end up getting a final value as 1. Similarly, if I will compute our this one common stopword maximum, in such case I will end up getting 1 by 2 because maximum of 1 by 2 is all about 1 by 2. It means 0.5. So that's a basic difference between both the feature, which is all about common underscore stopword underscore minimum and common underscore stopword underscore maximum. The core idea is, in this you have to apply the min function, and in this you have to apply the max function. That's the core idea. So let's try to implement all this stuff, or let's try to convert this pseudocode into executable code. Again, if you can understand the previous pseudocode, or if you can understand the previous code, writing a code for both the features is quite straightforward. Let's try to write a logic for both of the features. So what I will do is, I can think of just copying this function, and let's try to do some common modifications in the existing function that we have. So first and foremost, let's try to rename the function name. So I will say it is all about common underscore stopword underscore count underscore minimum. So whatever q1 q2 I will pass, we will end up getting 2 lists, which is all about q1 tokens and q2 tokens. Now, just to extract all the stopwords from both the list, you can think of removing not, which is all about our membership operator, and similarly not from this one. Again, just to make your stuff more user friendly, you can rename the list as, let's say, stop underscore list L1 or stop underscore L1. Similarly, stop underscore L2. Cool. You can say it as stop underscore L1 and or stop words. It's all up to you. I will say stop underscore L2. Sounds good. Similarly over here, minimum of this. Similarly over here, minimum of this. Now let's try to execute this line of code, and let's try to copy all the code. Let's try to customize with respect to our max. I can just customize the function name first and foremost, function name, and we have to just apply the max operation. That's it. Let me execute it. And what I will do is, let's try to call the function. First, let's try to cross check this. So I will say diff of question 1, let's say 0th index. Similarly, diff of question 2. Let's try to access data of 0th index. Let me execute. You will see you will end up getting a value as 1.0 or 1. Now let me show that. If I will say, let me execute, and if I will say, let's try to this time question 2. Let me execute. Now you will see in this stop word is all about is the by to in. Is the by to in. Over here we have one more in, probably what as well, of course what as well. So over here now you will figure out we have 6 stop words common. I will say minimum of 6, 7, because over here we have total 7 stop words and over here we have 6 stop words. Hence I can think of calling this. On the other hand, if I will say maximum of 6 of 7, which is all about nothing but 6 by 7, which is probably close to 0.86. In this case, it is all about 1. which is nothing but the value that we are getting. Let's try to cross check our this count underscore max function as well. Let's try to cross check that. So if I will say it is all about nothing but our max function, cool, let me execute. Now you will see you will end up getting a value probably close to 0.86. Now what you can do is you can think of applying this function using the apply along with the lambda approach, what I have shown you in the very first minute of the course. Let's try to apply that. So what I will do is let's try to customize this line of code what I have pasted. So over here let's try to store it in. First and foremost, our function name is all about nothing but common underscore stopword underscore count underscore minimum. This is the function name that we have, and let's try to store it in, let's say csc underscore min. And similarly I can think of calling with respect to our max. So I will say it is max and it is also our max. Now let's try to execute this line of code, and the moment I say df of head, let me pass some value, let's say 3. And the moment I will execute this line of code, now you can encounter you have two new feature which is all about these one. And if I will say df.columns, let's execute, and these are all the column names that we have. Look at this, we have two new feature which is all about csc underscore min, and we have the second feature which is all about csc underscore max. Again, for those of you who have any doubt with respect to the session or with respect to the logic, whatever I have discussed with you, feel free to ask with us in the Q&A of the course. That's all about it. Thank you. Have a nice day. Keep learning, keep growing, keep practicing.